The learning intention is to calculate the surface area of standard three-dimensional objects. So we have a few formulas that are given to us by the QCAA that are stated there. And then if we talk about the idea of what surface area is. So surface area is essentially the total area that covers all the surfaces of a three-dimensional object or solid. So if we think about a cube or we think about a square-based pyramid, as we've got here, okay, in these two places here, a cube, we can see the idea of unfolding it. Each of those 6 faces are the exact same, they're all a square. So the idea of the surface area for a cube would be 6 times whatever the area of one of those particular faces is. Okay, and obviously being a square, we know the area for a square is side squared. So whatever the side length is, multiply that by itself, square it, and then times 6, and that would give you your surface area of the cube. For a square-based pyramid, as we can see here on the right, so again, this time we want to know the area of the square from the base, but then we also want to know the area of the triangles. Now, because of the fact that it's a square-based pyramid, each of these 4 triangles will actually be the same size, okay, because they're all going to have the exact same length along the base there, okay, and they all have to have the same height. So when we go about an example, so our first example we've got is a square-based pyramid. It's quite important to draw the net just so you can visualize exactly what the shape looks like. So down here we've got our net, and you can see we've got our square base from the pyramid, which was 8 centimeters by 8 centimeters, and then we have each of our triangles from the pyramid, and again they have a height of 6 centimeters, which we've stated. Okay, so when we go to look at surface area, we've got the one square plus we've got the triangles, and we've actually got 4 of those. Okay, so they've shown it as plus another triangle, and a third triangle. So 4 triangles in total and the one square. So when we do our working, we can say that the total surface area, TSA, equals. So in this case, we've got the area of a square. And I'm just going to draw a little, not very neat. I might use the word square. Area of a square plus the area of a triangle times 4. So the area of a square, the rule for that is side squared, or you can use length times width, plus the area of a triangle is half base times height, and then we're going to multiply that through by 4. So then we can go along and we can work out which values we have. So our 8 is our side length, so S, and our 6 is the height of the triangle. Now the base is actually this length here, which is also the same, the 8 centimeters, okay? So 8 centimeters there, which is our B in regards to our triangle. So to substitute those values in, we have our side, which is 8 squared plus half. Now, again, like we've been saying, we don't have times there, but you need to know that it is multiplying between each of those variables. So half times the base, which is 8, times the height, which is 6, and then times 4 because there's the 4 triangles. So to put that into the calculator, we can do it all in one go. We can do it, I'm going to mentally do it now. So we'll break it down. So 8 squared is 64 plus, now we want to know the area of the triangle. So 8 times 6 is 48. Half of that is 24. And we're going to need to multiply that through by 4. So we end up with, and ideally I should be working down, I've just run out of room, 64 plus now 4 lots of 24, 4 20s are 80, 4 4s are 16, so we're talking about 96 when we add those together. And if we add those two together, if we add the 4 on to the 96, we get 100, and then the 60, so 160 centimetres. Now for surface area, we're talking about area, so the units are going to be squared. Okay, and that's it. So the easiest way, as I said, is to take your problem, draw a net just so you can visualize what shapes you actually have, and then break it down into the actual shapes, whether it's a square, a triangle, a rectangle, parallelogram, whatever it may be, and go from there. So then it becomes quite easy. It's just a matter of adding up the correct number. All right, so let's have a look at another example. So before moving on to an example, we've actually got a few special cases. So just then we looked at a prism. So any prisms, like a triangular prism, even an L-shaped solid like we saw, it could be anything like that. It's just a matter of breaking it apart. Now with these special ones, so the cylinder, the cone and the sphere, they actually have a little rule that we'll use. So a cylinder, if you think about it, it can work the same idea. So we can still draw a net. So if we unrolled it, if you can imagine like a tin of Milo or a can of baked beans or whatever it is, and you took the label off, that label would in fact be a rectangle. Okay, so this space here ends up actually looking like a rectangle. So then if we have our rectangle, we then have our two circles at the top and at the bottom. Okay, and that's our net for our cylinder. So you can see above, when they've come up with the rule, the area of this, well, we know for a circle, the area of a circle is pi r squared, but not only do we have one and we have two. So we actually need two lots of pi r squared, which is what they've done here. They've said 2 times pi r squared. So then the next part is, well, all right, if we think about our height of our cylinder, when we unravel that, that's actually this height here. Okay, so that part's easy. But how do we know the length of this section through here, the length of our rectangle? How do we work that out? So it is in fact, I'll just use another colour for the moment, that length there is in fact the same length as our circle. Okay, so I'm just going to move those just so we're not doing it messily. But yeah, basically we know it's our circumference. So the rule for circumference of a circle is 2 pi r. So if we want to know the area of our rectangle, well, normally that would be length times width. But in this case, instead of length, we've got 2 pi r, and instead of width, we've got height. So it ends up being the area here is 2 pi r times h. And that's what they've got in the second part of the formula. Now, they then go into factorising that. So they actually work out a common factor. So 2 pi r goes into both of those two terms that I've underlined. So in fact, we have 2 pi r out the front. And then what are we left with from the first one? Well, if we pull out the 2, the pi, and one of the r's, we're only left with 1 r. For the other one, if we've put out 2 pi r, well, we're just simply left with the h. Okay, and that's where the r and the h come in there. I personally would just be happy enough to use the top one. If we look at the one that we get from the QCAA, which is what you'd be given, they have in fact used that first example. Okay, so I think even though they have shown you how you can use the brackets, I would just keep it simple, and I'd say, look, the idea is we've got 2 circles plus the rectangle, and I personally, I'll just tidy this up because I've got colour everywhere. I personally would just use this rule here, not worry about the other one. Okay, all right, so then for a cone, again, if you can imagine drawing the net of that shape, you have your circular base, so we have our circle, and then we end up with a shape something like this. Okay, probably a bit wider, but oh no, we didn't want to undo that. So something like that. So when we have that shape, we know that the area of a circle is pi r squared, and this shape here, the area is actually pi rs. Okay, and the s being the slant height of the cone, so this value here. So pi times the radius times the slant height. So that one's quite simple. It's simply just adding the two shapes together then. So the final rule becomes the pi r squared plus pi rs. All right, and then the last one we've got is a sphere. So for a sphere, we're just looking at 4 pi r squared. So for whatever reason, when mathematicians have come up with it, they've actually figured out that a sphere, the surface area of it is just 4 lots of the circle that would be the circle that we can see in the centre of the sphere. So if we took the area of that and multiply it by 4, that actually gives us the surface area of the full sphere. Okay, so mathematics is pretty cool like that. Sometimes things just work out quite nicely. So all you need to do is just 4 times pi times your radius and squared, and that's it for a sphere. Really, really simple. Okay, so let's go and have a look. So they've just broken the cylinder down the same as I've shown you. So for our first example, we have a cylinder, okay? And so again, if we draw our net, we know we've got our rectangle, and we know we've got our circle and our other circle, okay? So when we go to do our rule, we write our TSA, total surface area, equals, and our rule is 2, because we've got 2 circles, so 2 lots of pi r squared, and then plus, and it's 2 pi r, which is our circumference. So remember we talked about the idea of the circumference being 2 pi r, and then we multiply it by the height, so just times height. So to substitute that in, our r value is our 8.5 and our height is our 15.7. Now, sometimes when I'm trying to explain this in class, the idea of a height, most people think of being up and down. But I always try and explain, well, hang on, so my height is 172 centimetres. Now, if I'm still standing up, I'm 172 centimetres, but if I'm laying down, I'm still 172 centimetres. My height doesn't change. So my height doesn't all of a sudden, when I'm laying on the floor, become the height of, how high I go off the ground. It's still my height from my head to my feet. So whether a cylinder is on its side or it's upright, height always has to be the distance between the 2 circles, okay? So we simply now can just sub those values in. So the rule tells us, and again, we multiply in between each of the terms. So 2 times pi times our radius, which is 8.5 squared, plus 2 times pi times our radius, again 8.5, times our height, which was 15.7. Okay, and we're just going to put that in the calculator. So 2 times, now again you'll use your pi button, times 8.5. You can use your little, remember I've talked about your x squared button. So find your x squared button, hit that, plus 2 times pi times 8.5 times 15.7 equals, and you can see that I actually could do that all in one go. So I could in fact go through and put, even though they're broken into 2 sections, the calculator knows to make sure that it multiplies first and then it does the other multiplications and then adds it as the third step. That's fine. So now we'll say approximately equal to 1,292.45, and the units are going to be centimetres squared, being area. All right, last example. So our last example is a sphere. So our total surface area for the sphere is 4 pi r squared. So 4 times pi times 5 squared, and we just put that in the calculator. Really, really simple. Okay, so 4 times, we hit our pi button, times 5 squared equals, and it gives us 314.16. Oh, and that one's millimetres. My little boy's just woken up. Millimetres squared. Hang on, Bobo. And yeah, so that's pretty much it, guys. The only thing you'll find is obviously we were given radius for those last two examples, so we may need to work out the radius. If we're given the diameter, we'll have to halve it. Okay, so that's the only difference. But